Illustrative Math, Algebra 2, Unit 3, Lesson 12 is called Arithmetic with Complex Numbers, okay? So let's make sure that we remember what a complex number is. Complex number has a real part, which we call A, plus an imaginary part. So it'd be like something like this, 5 plus 6i, or maybe like -3 plus 2i, something like that. Okay, that's a complex number. So, goal, I can add complex numbers and calculate powers of imaginary numbers. So remember what's an imaginary number, what's I. Another review thing, I is equal to the square root of -1. And then we learned if we square both sides, I squared is going to be equal to -1 because the square undoes the square root. So we know two things right there. We know that I comes from the square root of -1 and I squared is equal to -1. All right. Warm up. Pause the screen, give this a try on your own. Find the value of these expressions mentally, okay? So obviously this first one, without a calculator, these two cancel out. 2 minus 2 is 0, 20 minus 20 is 0, 200 minus 200 is 0, so the whole thing is 0, okay? Coming over here, it's kind of the same idea, it's just switching the order. They don't put them right next to each other. 100 minus 100 is 0. -50 plus 50 is 0. 10 minus 10 is 0. Again, same idea here. The 3 minus 3, 0. 2 minus 2, 0. 1 minus 1 is 0. 0 plus 0, 0. And let's see here. 1 minus 1 is 0. 2 minus 2 is 0. 4 minus 4 is 0. 8 minus 8 is 0, and then 16 minus. So we were left with 32 on this one. Okay. All right, so here's a diagram. We have two complex numbers that we're adding together. So remember, this is your real axis. This is your A. This is your BI axis. Okay. So 2 plus 3i is going to go right to up 3i. So this is my first number here. It's my 2 plus 3i. So basically, we start here. So we got to start at the origin, go to the right 2, up 3i. And there's my first point. So then this is going to be my next starting point. So then from here, I go left 8. So I go 1, 2, 3, 4, 5, 6, 7, 8, and then down 8i. So that's how I end up right there at that point. Okay, so this point here is not -8 minus 8i. -8 minus 8i is like, like down here somewhere, left 8, down 8i. So this point here is right there, the addition of it. So how do you see 2 plus 3i represented? I would say that would be right here. Let's call this, I don't know, I'll just name it. I'll say point P. How do you see -8 minus 8i represented? I would say we move left 8 and down 8i from point P. What complex number does A represent? So that actually represents, if I look here, A is right here. So I go left 6, down 1, 2, 3, 4, 5i. So that's going to be -6 minus 5i. Oh, my I is a little sloppy. Let me rewrite that. Okay. Add the like terms in this expression. So when I say the like terms, we're going to add the real numbers. So what is 2 plus -8? Well, that's going to be -6. And then I add the imaginaries. 3i minus 8i is -5i. So it coincidentally looks like the same value. So that makes things a little bit easier. You don't want to have to graph every time you're adding complex numbers, which you could. You could do it. But here, we're just going to add the real part, add the imaginary part. So we'll do it kind of the same. Add the reals. You know what? I should use the same color I used before. Add the reals, add the imaginaries, and that will be my solution. So negative 3 plus 4 would be 1. 2i minus 5i would be negative 3i. Over here, negative 37 plus 11 is negative 26. Negative 45i plus 81i. It gives me 36i. Negative 3 minus 4. So this is kind of different because it's minus. So you have to like kind of distribute this negative to both of these. So if you wanted to change it to an addition, you could. You can make it negative 3 plus 2i plus, and then you just change both signs. Okay, and then you could do it just like we did. So it'd be negative 3 minus 4 is negative 7 for the real. 2i plus 5i would be 7i for the imaginary. You might be able to just kind of mentally distribute it. You could do negative 3 minus 4. You could do 2i minus negative 5, change it to a plus kind of in your head. You don't have to write that extra step out, but I like to do it that way when I'm first teaching it to make sure everybody sees what's happening. So the first one is like that. I'm going to distribute the negative, change it to addition, negative 11 minus 81i. And then I can add the reals. So negative 37 minus 11 is negative 48 for the real. Negative 45i minus 81i is going to be negative 126i. Okay. And I know it said check your work by drawing a diagram. I'm not going to draw a diagram because I don't want to count out 81 and negative 45 and all that stuff. Okay. All right. Draw the points 2, 2 squared, 2 cubed, 2 to the 4th on a real number line. Okay. 2 is right here. 2 squared is at 4. 2 cubed is at 8. 2 to the 4th would be at 16. Right. 2i squared, 2i cubed, 2i to the 4th in the form a plus bi. Well, 2i, well, that would be 0 plus 2i for the first one. So this would be 2i. And then we're going to go here, 2i squared. When I square that, I'm going to get 4i squared. And remember, I squared is negative 1, so this is negative 4. It's 4 times negative 1. Okay, so really it's going to be negative 4 is my real part. It's plus 0i. So there's that one. There's this one. The next one. We'll go down here. 2i cubed. 2 cubes 8. I cubed. Now we haven't learned what I cubed is, but we could probably rewrite it as 8i squared times I. That still adds up to 3. Now we know what I squared and I are, so it's going to be 8 times I squared is negative 1 times I, which gives me negative 8i. So if I wanted to write it as a complex, it'd be 0 minus 8i. And then the last one, 2i, the whole thing to the 4th. Well, 2 to the 4th is 16. I to the 4th, why don't we write it as I squared and I squared, because those would add up to 4. So it's 16 times, remember I squared is negative 1, so that's going to be negative 16. So if I wanted to write it as a complex, it'd be plus 0i. Okay, so let's do this. I'll call this A, B, C, D. Okay, so A, B, C, D. So A is going to be 0 plus 2i. I think these go by 4 i's. It's kind of hard to see. I should have made the graph a little bigger, but they're counting by 2's because it goes up to 4i and then 8i. So there's A. B is negative 4 plus 0i. There's my B. Let's see here. C is 0 minus 8i. That's down here. There's my C. And then D is negative 16 plus 0i. Okay. There we go. All right. How are complex numbers and real numbers similar? How are they different? Okay. How are they real? Or how are real numbers and complex numbers similar and different? I would say you can add and subtract them. You can add and subtract complex numbers. Like you can do with real numbers. You can graph complex numbers on the complex plane. And you can graph real numbers on a number line. So I would say that's kind of similar and different in the same sentence there. What else can you do? Let's say different. Real numbers only have a real part. Complex numbers have a real and imaginary part. Imaginary numbers contain the square root of -1, and real numbers do not. All right. So goal, I can add complex numbers and calculate powers of imaginary numbers. I guess the second goal here, calculate powers of imaginary numbers, I guess it was kind of not really very well done because we only did a couple things. So I want to make sure you understand here, if I have I to any power, let's say I to the 8th, you can break it down into any power of 1 and 2, as long as the numbers add up to 8. Okay, so every I squared is -1, so you can kind of just simplify it all the way down. So then you get -1 times -1 times -1 times -1 would be +1. Okay, and let's say I had I to the 9th. Well, it's I squared, I squared, I squared, I squared, and then you got one I left. So all of these are -1, and then you have an I left. So these 4 here are going to be 1 times I, which is just I. Okay, so anytime you have a power, just rewrite it down as many I squareds as you can. If it's an odd number, you have 1 left over. If it's an even number, you'll have no I's left over. All right, do one more here. I to the 6th. I don't know. Let's put a number in front of it. Let's say 3I to the 6th. It's going to be 3 I squared, I squared, I squared. Every I squared is -1. So I have 3 negative signs. So this whole thing is -3. Okay, hopefully that clears that up a little bit. That was kind of weak on that lesson. Adding them is pretty basic. I think we're good with that. All right, so here we go. So K and M, write each expression in the form A plus BI, where A and B are real numbers. So K plus M. So 3 minus 4I plus -2 plus 9I. So add the reals. 3 plus -2 would be 1. -4I plus 9I would be 5I. Okay, so you always want to make sure the real part goes first because they want it in A plus BI. We don't want BI plus A. We don't want to write it backwards, okay? So K minus M. And I like to distribute that negative, so I'm going to rewrite it. I know it's a little bit of an extra step, but it makes sure that you don't miss a negative sign. I've seen so many people only change the sign of the first term and forget the second term. It's a very common thing. So I'm going to try to do it in a way that'll minimize your mistakes. So I end up with 3 plus 2 would give me 5. Negative 4i minus 9i is negative 13i. All right, so now I got to write this in the a plus bi form. So I guess maybe on that last one, I should have written it as, 1 plus 0i, negative 3 plus 0i, and this would be 0 plus I guess technically if I wanted to put in the a plus bi complex form. So let's see. So notice the negatives on the outside of the parentheses. So it's really just one negative sign. You're not taking that negative sign to the third power. So I am going to cube the 3, and I am going to cube the I. So don't include that negative sign to the third power. It's just one negative sign. So 3 cubed is 27. Bring this negative sign down. I cubed. See if you can write it as powers of I squared and I. So 2 plus 1 would be 3. So now we know that I squared is negative 1. Negative 27 times negative 1 is positive 27i. So that's the imaginary part. That's the bi. So a would be 0 because we don't have a real part. Okay. So, all right. Hope you enjoyed this lesson, and thank you for watching.